All right, here we go. Section 7.3, we're starting out as rational exponents. I am giving you all of the notes today. Okay, you notice I'm not, you talking about a flipped video? Okay. The flipped video, I might overlap just a little bit. This is the whole section. What you did on the flipped video is just a little blip. In fact, it's probably just example 1. Okay. You're going to want all of this. This is all of the notes. I've given you basic examples. We will do our own practice examples at the end. And I won't get through all of it. I just won't. Okay. This needs to be split up more for your sanity, if you will, because we are changing gears.
What is beside the B and 1 that we have?
One.
The exponent?
1.
That's what I thought.
Mm-hmm. Yeah, that is a 1. So number 1, we are talking about b to the 1/2. This is an exponent. Okay, just a reminder. Exponents are not numbers, they are powers. Okay, the exponent tells you the power of what the base is. Believe it or not, when you have a fraction as an exponent, it makes that base smaller. Okay, you know this, you just don't know you know it. Okay. You know this to be read as the square root of b. Am I right? Y'all have seen this before. This is very familiar. So reading this, you hear yourself saying the square root of b, right? Do you hear the word square? Okay. It is understood that that too is there. Okay. We don't write it though. That number is understood to be there, just like the exponent 1 is understood to be there. That's where the 1 comes from here. And this 2 is the same 2 there. Do you see? Okay, but for both scenarios, those are understood to be there. Okay, so you know this, you just don't realize you know it. Did y'all know the square root of b or any number is actually an exponent? You probably didn't. Okay, it is. It's a fractional exponent or rational exponents. All right, well, looking at the example here in purple, 16 to the 1/2, if you write that in radical form, which is this here, guys, you know, what is the square root of 16?
4.
What does it mean? 4 times 4. Okay, 4 squared. Again, the square root of 16. Do you see how you know it? You just didn't know you know it. Okay, so another example is 38 to the 1/2. Okay, hopefully you recognize that's not a perfect square. 38 is not. So here you are, the radical, okay, little tidbit of information because we're going to go through a lot of language here. When I say radical, I'm talking about this fancy little house thing right there. Okay, you're going to hear me say radical a lot. Okay, while we are here, I do need to review perfect squares with you. We're going to stop when we can stop, but can we do that together quickly? Okay, I want us to do it all together. What is 1 squared?
1.
2 squared.
1. I mean 2.
2 squared is 2 times 2, which is
4.
4. 3 squared.
9.
4 squared.
16.
5 squared.
25.
6 squared.
36.
7 squared.
49.
8 squared.
64.
9 squared.
82.
10 squared.
100.
11 squared.
121.
121. 12 squared.
144.
13.
130.
169. We'll stop there. Okay. Be familiar with that. So I'm doing that because square root of 38, hopefully you recognize that's close to 36, and there's not going to be a perfect square until 49. This is actually 6.2-ish. Okay, so it's close to 6. Do y'all see that? If you put this in the calculator and you get an irrational number, which is a decimal going on and on and on, it doesn't stop. Okay, this is between 6 and 7. Okay, y'all have learned this, it's been a while, and I understand that. Okay, it has been a while. All right, can we move up? Yes, sir.
If it is an irrational number, do we have to write it down like we did for 16, square root of 16? Like it has 400. If it was irrational, would you have to put it?
You leave it as a radical, yes. Because, very good question. This section leads us into section 7.4, which, to be honest, I could test you alone on 7.4. I could give you a test. It's that loaded. It's probably going to take us a week, maybe more, to do section 7.4. It's all radicals. It's all simplifying these. Okay. All right, so let's look in orange. This is important. B to the 1/2 is an exponential form. What word do you see in this? Exponent. So this is the same thing here. Y'all see that? Two different ways to write it. Okay. This is exponential form. Okay, the obvious part is exponent is in the word. You have the exponent. This is called radical form. Well, I just told you this cool little house thing, it's called a radical. Okay, y'all okay with that so far? What you're going to be expected to do is go from exponential form to radical form, from radical form to exponential form. Okay? All right, so let's move on to number 2. This is kind of, we'll come back to this tomorrow. Okay? It's a little out of order, but I went ahead and write it. 2 to the 4th power equals 16. Well, what does this mean? Simply that. Trust me, tomorrow we'll come back. Okay. Number 3 is actually really important. Star it. We're kind of a formula. If you need to go from exponential form to radical form, this is where the math comes in. This is where, now we will be using our calculators, but you know how I am about that. Today I want us to use our minds, okay? Because it's really, you'll see. And number 4, if you can go ahead and write that one, we are not talking about 4 at all. 2 and 4 actually kind of go together. Okay. And I'll let you catch up and we'll go through some examples. I feel bad for those that are home virtual, just because this video is going to be really long. And I know that's just, when you're at home, it's just different. You don't want to watch a long video, but if there's no other way to do it. So when you're done, if you don't mind putting your pencils down so I know who's done, what we're going to do after this is I'm just going to go through just as many examples as I can. And you're going to see there's different ways, yeah. Because, well, you'll see. Just to clarify, if you did not finish the riddle sheet, that is due tomorrow, okay? I am going to, no, I'll wait. While we're waiting, y'all know you don't have school Wednesday? Okay. Is JV basketball over? Okay. How'd y'all do? How'd you do? Friday. Yeah. Don't want to talk about it?
No, we didn't do bad, but like we still lost.
Okay. So you ended on a good note. Even though you lost, you ended positive. What?
Is that a positive?
Hey, you can always find the positive.
Pretty sure we lost by like 2. We lost by like 4.
So was it really close to the last second?
Yeah, we went to like overtime.
Oh, you did? Oh, man. All right, well, good game. So what do you do next? Anybody doing spring sports? I know you're doing soccer. Are you doing soccer? No, it's fall. Track. Who else is doing a spring sport? Luke?
I might try to do baseball.
Baseball, softball, I know that. Baseball?
Yeah.
Why are you not saying it?
Yeah. I just go along with it.
Austin, anything? Nope, it's all right. Anybody else? Hey, you do you. That's what I tell my kids. You do you. I will say I'm excited because I'm going to have one at the baseball field and one at the soccer field. Maybe. I mean, if it works out. What are the odds of it working out? Slim to none is probably right. Yeah. Who knows? My older daughter has her first college game tomorrow night. I know, I'm excited. I get to go to Greenville.
Which sport?
Soccer. What was you're a striker, right?
No.
No, what are you? Midfield.
No, yes.
Where? Are you outside back?
Right back.
You're right back. So you're fast. She's center back, holding mid.
You have to be commanding out there.
She's really, she's kind of scary, I'm gonna be honest. Am I right? Keegan, you know Maggie. She's a little scary, right?
Yeah.
And I say this on the video. She's 5'11", and she is not scared to in a second. So the other day, anybody football players in here? 7-on-7. Did you go? Okay, so Tommy, my son, plays football, and there's this 7-on-7 thing, whatever. So this kid Saturday night, I was not there. What's that? He swung at Tommy. And if you know Tommy, he's like the nicest kid ever. And he's like, wait a minute, I got the whole replay from Gunnar Mowing. Yeah, it's funny. And it's funny, like in different scenarios, I'm like, if that were Maggie would have like thrown down with him. Like, yeah, it's just so funny how my older child, who is a girl, got the, I mean, don't get me wrong, but Tommy's like, yeah, don't swing at me. I'm out. Gunnar said Tommy just like kind of ran away. It got a little dirty, really dirty, actually. Anyway, so hopefully I can watch baseball and soccer.
Are you talking about the soccer field down here?
Where the football field, yeah, that's what,
Yeah, that's where we use.
yeah. So my 8th grader will play. We'll see. And then softball. It's fun times. Yes, you do.
It doesn't make sense because in travel you don't have to worry about it. Travel is like nothing ever happens.
I know. It's kind of crazy. Okay, so let's start with some examples. I'm going to rewrite these because I want to give you a break just because I need your mind fresh, okay? All right. Look at all that we're getting ready to, oh, we'll do more. I'll do more with y'all. We have more time. For some reason, first period I ran out of time. So I'm not finishing this section, just letting you know. I'm only touching the surface. Okay. All right, let's do some examples. Number 1. Look at 1 and 2. So the directions are, okay, first of all, what form is number 1 in? Exponential. So what I want you to do is write it in radical form. Okay. This one and, well, number 1 is very basic. Can I not count? 1, 2, 3. Sorry. Okay. Who's got number 1? It's pretty, Adriana.
Radical 12.
Yeah. Here you can say the square root of 12 because that's actually what we're using, the square root of 12. Okay. Any questions on number 1? There's nothing tricky about this. Yes.
I feel like when we were doing house thing, whatever it's called, you put the denominator outside of it and then.
Yeah, okay, so this is where the 2, you're talking about the 2? Yeah, but you don't write the 2 because it's understood to be there. If it makes you feel better, go for it. Okay? But for the radical, it's understood to be there. Okay, so you're right. Yeah. Yes, ma'am.
So once you write it like that, then you don't have to do anything else?
No, that's it. No. Now, you can do more.
Because I didn't know like what you do with like the 2 on the outside.
Okay, forget that's there. This is all I want right now. I just want this in radical form. Okay, that's all. Number 2, I do want to make sure we have this one right because I have a feeling some of y'all did not do it right. Okay. Everybody look at the 3 and then look at the x. What does the 1/2 belong to? Just the x. So, okay, I'm going to talk about well, I'll come back. So what do I do with the 3? You just put it on the outside. You don't do anything with it. So the sheet y'all just turned in a minute ago with the riddle sheet, you had some variables that you really just moved over. You didn't do anything with, right? There was no negative exponent. There was nothing left. You just wrote it again. Okay, well, this 3 is kind of lonely. You just write it again. So the x is inside the radical. Okay, do you see? Now, we'll come back to that. All right, so look at number 3. What form is number 3 in? It's in radical, so let's put it in exponential. 33 to the 1/2. And that's it.
Will it always equal 1/2 when it's radical form?
You mean to the 1/2 power? As long as there's not an exponent here, and this is understood to be the square root, yeah. Do you think we're going to stay with 1/2? Austin?
So if there was an exponent there, would it just be?
We'll get there. We'll get there. Yeah. Okay, look at number 4. I want you to look at your answer in number 2, and then look at number 4. There is a difference here. What is inside the radical? 8n. They are both inside the radical. What is only inside the radical in number 2? Just the x. So this is different. Okay? Guys, keep this 8n together. Do you remember how to keep them together? What should you write? Parentheses. 8n. It's kind of like they're married, okay? And they're in the house together. So my exponent here is just 1/2. I'm getting there, so just wait. It's going to change. But number 2, they are not together. They are completely separated. The 3 is lonely. Remember I said the 3 was lonely? There's no parentheses. So it's almost like you got to focus on together or not together. Okay, I know that's so cheesy when I say married and together, but you got to think that way. Okay. All right, Austin, you asked for it. Here we go. Somebody read number 5. What does it say?
312 to the square root of 8.
It's not square. What is here? Cubed. The cubed root of 312. So, actually, it's a typo. I was like, that's not what I wanted to say. Change that to a 5. I knew something wasn't right there. Sorry, my fault. Cube root of 512. What does this mean? A number times itself 3 times gives you 512. Now, can you put this in the calculator? Oh yeah, but we've got to get our mental math turned on, okay? Because you're going to need the mental math and you're going to need your calculator all at the same time here shortly, okay? What number times itself 3 times gives you 512? Guys, let's listen. No, hold on. What I'm saying is a number times itself 3 times equals 512. I want you to mentally, as a class, let's figure this out. Now, can we try 2? Let's try 2, even though we know it's not the answer. What is 2 times 2 times 2? 8. Okay, that's not going to work, right? We need to get to 512. Okay, 3. What's 3 times 3? 9. 9 times 3 is?
27.
All right. Wow, we're far away. Try 4. 4 times 4? 16 times 4? 64. It's not it. Can we try 5?
No.
Common sense. Why? It is not a factor of 5. This 2 tells me it's not a factor of 5. Every factor of 5 ends in either a 5 or a 0. So let's move on. 6. 6 times 6? 36 times 6? 216. I cheated. Got my calculator. Okay. All right, so we're getting close. 7. 7 times 7?
49.
49 times 7? 343. Guess what? The answer is 8. 8 times 8?
64.
64. 64 times 8? 512. So, this is, first of all, you don't have to do that step. For these 3, really the answers are simplify. The answer is 8. Now, do you want me to show you how to do it on the calculator?
Yes.
Okay. All right, does everybody look? You're going to want to see this.
Can't you just press the square root button?
This is a cube.
You can't?
Nope.
Yeah.
Huh? All right, so look, this is where it's helpful that you know how to write it, because you're going to need to know how to write it. You can't see that, can you? Is that better? Yeah, okay. So I have 512. Now, you can use the radical and put the 3 up there. I'll show you that next week, remind me. So here's what I'm doing. My exponent button is there. Is that better? Okay, I'm going to use a parentheses. 1 divided by 3. Close parentheses. Can you see it? Here, I'm not going to take time on the calculator. Okay. This says that. Can everybody see at least what's on the screen? Okay. Done. Okay, what is probably the most important part of this? If you don't use parentheses, wrong. If you don't close the parentheses, wrong. So this is why I hesitate this early to show you, but you'll get there, okay? All right, so let's look at number 6. What does this say? Somebody read this out loud.
200 with the,
I don't know this one.
What number is that?
5.
5. The fifth root of 243. Wow, that's a mouthful. What does that mean?
243, 5 times, no, 243.
Number times is five, number times itself
Yeah.
5 times.
There you go. A number times itself 5 times gives you 243. Okay, here's a question. Look at this number. Should I even try to?
no.
Why?
Not possible.
Right, this is an odd number. Every factor of 2 is an even number. Therefore, every factor of 4, well, does anybody know this? I forgot, actually. No, let's try 3. Oh, because I know it's 3. 3 times 3?
9,
9 times 3.
27.
27 times 3. 81. 81 times 3 is 243. All right, number 7. Oh, now we're really getting into it. Okay, what form is this in?
Exponential.
Exponential. So this can be read as 243 to the 2/3 power. Do you see how the power, when it's a fraction, it really breaks up that base, how big the base is? As soon as you made this exponent a fraction, it changes the power. Okay, that exponent has a lot of control. Okay, I want you right now to rewrite this in radical form. Now, you will need your notes. You will need to look at number 3 on your notes. How do you write this as in radical form? Do it now. Okay, so I have written, if you remember, where are my notes? Here. Here is my notes that I gave you. Does everybody see number 3 really has some weight to it? You see that? Okay, I have written both forms. One is way more friendly than the other. I'm talking about that one. Okay, why? Look at the number inside the square root. Okay, somebody, well, I'll just do it because I'm running out of time. I'm going to square this number. Y'all have any idea how big it is? Look how large that number is.
11.
Who wants to mess around with that? Now, if you have your calculator and when you're confident, you can do that. I would much rather deal with 343, okay, since we're working on mental math as well. Okay, I'm really covering a lot of ground today. Mental math is very important with this. Section 7.4, you will need mental math more this year than you have yet. Okay, 343. So what does this mean? What number times itself 3 times gives you 343? Is it going to be 2? Can we eliminate 2? Right, eliminate 2. It's not 3. 3 to the third power is 27. 4, no, that's 64. What about 5? Why is it not 5? Right, it's not a factor of 5. You can look at it immediately and say, yeah, I'm done with 5. 6. 6 to the third power is 216. It's 7. So let's just say 7 to the third power is, good, 343. So I have 7 squared. Do you see how that's what that number says? So the answer is actually what? What's 7 squared? 49. Okay. I'm going to stop there. I caution you, I've only touched the surface. Okay? It's not going to get harder. It's just going to get, we're building. We're building. Okay? I am giving you this sheet. Okay? I need this to be back tomorrow. Your homework is part of this. So if you'll let me pass this out, okay, you're going to do part of this for homework. We will finish most of this in class tomorrow. Okay, now here's my plan. Okay, I have created a very basic online quiz for you to do since you're off Wednesday. It's going to be due on Thursday. That's your assessment for the week. Okay, it's really just what we're doing here. Okay, does that make sense? All right, so we're going to finish this tomorrow. And I won't see you again until Thursday. I don't want to get too far ahead, but that's my plan, okay? So if you want to go ahead and write your name and get situated. My point is don't lose this sheet. Although I think I put it on LMS. That means I'm really, if I put it on LMS, then that means like I'm on top of it. Mental math, why is mental math so important?
Because we won't.
Can't use a calculator.
No, okay, that